the way we have got, in some sense, to a model synthesis of the two. So what is uniformity? This guy was called Charles Lyell. He was a young man when he published his book, Principles of Geology. The basic principle he was trying to propose is called uniformitarianism. He said that everything which produces the shapes of the Earth we see now must be the product of phenomena which operate every day. As an example, small sedimentation with sanded pebbles at the bottom of a river, or maybe where the river ends in the sea, can accumulate to strata which are kilometers. This theory had enormous influence on all natural sciences. Just to give you one example, when Charles Darwin left on the Beagle for his tour of the world, the last book he bought was volume first of Principles of Geology. And this was the book he read on the Beagle while going away, and then while he was in Argentina, he managed to receive the second volume, which has appeared in the meantime. Now, can you change, please? Sorry? Sorry, I don't understand you. Sorry.
It will not be simultaneous translation, just expect to be.
Okay. I'm sorry, but I don't speak Serbian.
That's another controversy. Starting now. Sorry.
Now, and nevertheless, there is also another kind of natural phenomenon which are catastrophes. And catastrophes do happen. So this example I'm showing you is something familiar to any geologists, but also to many tourists, because this is actually Grand Canyon in the United States in Colorado. And here you see a wall which has been cut for a depth of about 1 mile. And here you see these layers of different color composition. And in principle, these layers correspond to geologic ages. It's part of the typical skill of a geologist to be able to pick up a piece of rock and tell you this is Cretaceous or this is Permian, okay? So that means what? That even a small piece of rock here and in another layer are different enough, in particular in the composition of the flora and the fauna, to be able to distinguish between the ages. Therefore, this is possible because there are discontinuous changes. If there was a smooth transition within geological ages, nobody would be able to find them at these boundaries. On the contrary, these boundaries not only exist, are essential for geology, and some of these are extremely thin. Some of these are at the level of 1 centimeter or less, which means catastrophes happen. That is violent transition during which a very significant fraction of the species existing in the previous geological age can take place, and some of these take place in a time which is essentially an instant on the geological scale, like a few thousand years, not millions of years. That means that geology, which is the theory which was most developed on the basis of uniformitarianism of Lyell, cannot do without catastrophes. Both things are necessary. Now, this talk is not about the theory of evolution, but maybe if you have some idea of modern theory of evolution, also the modern theory of evolution exists in a uniformitary version, which is the one of Darwin, but also in a catastrophist version, which is the one of Stephen Jay Gould, as an example. Okay. In modern theories, essentially you need both extinction of species, uniformitarian and catastrophic. Next. So, what is my goal today is to explain to you a phenomenon which is uniformitarian and catastrophic at the same time. The key of this possible synthesis is that natural phenomena typically happen in different scales. You can have small versions, which are more frequent, and large events, which take much longer time. It's a familiar concept, like earthquakes. How many earthquakes we have every year? Thousands. But then once in a while there is a big one. So one uniformitarian phenomenon is the fall of meteors. What is a meteor? Meteor is a small pebble. The smallest one you can see by eye are about 1 centimeter. And with radar it's possible even to see ones which are 1 millimeter. When they are 10 or more centimeters, you sometimes see, this is rare, but you can see it. Something like a small firework. It is a meteor, but then it makes poof. Okay? When they are meters, they can make a big explosion. And they have multiple explosions decomposing pieces. And on the ground, you can have a shower of stones, which are called meteorites, will actually fall down from the sky. And this happens every day. Every day, tons of meteorites are deposited on the surface of the Earth, all over there. And these tons arise from small celestial objects which impact on the atmosphere, first become heated for meteors, then blow up and launch small pieces, fragments on the surface. So this happens all the time. So this is an example, it's called the Peekskill New York bolide. This was a meteorite which was kind enough to arrive above a stadium in which there was a baseball match, I remember well. So it has been, was until recently the most photographed such event in history. There were hundreds of video cameras showing it. Also, just for your amusement, the total mass was over 10 tons, diameter larger than 1 meter. Only 12 kilograms of meteorites have been recovered on the ground because most of it was destroyed. Well, just for your amusement, this meteorite destroyed a car. Okay? And then the owner of the car sold it to a museum for a price much larger than the price of the car. Then you know what the rate was sold. Okay, next. Now, sometimes meteorites are a little bigger. Now, I'm going to the other extreme. This is the largest meteorite ever found in a single piece on Earth. And as you see, it's something like 4 meters. It has a very strange shape, very flat. And this you can find in, well, if you happen to go to Hopa, Namibia. Most meteorites don't behave in this way. They go into many pieces. Either they explode in the atmosphere or they explode upon contact with the surface. Even larger asteroids can make a big explosion. As an example, in Tunguska, Siberia, in 1908, one particular object, which was believed to be about 40 meters diameter, exploded in an explosion of 3.25 megatons, millions of tons of tritium, high explosive. Okay? The megaton is a unit normally used to describe the effect of nuclear weapons, but it can be used, because the same concept, a way to express the intensity of an explosion. Please understand, there is no atomic weapon in asteroids, there is no explosive either. What happens is just that the kinetic energy of the impactor is transformed into heat, and this produces a fireball. Next. Okay. I was telling you, speaking of the most photographed event in history until recently, and then on February 15, 2013, at dawn in the city, people arriving at the city of Chelyabinsk for their daily work, saw this scene, something like this. Now, the thing which is most peculiar, this has now become the most photographed event of this kind in history, of course. Actually, the most video recorded event, because it appears that in Russia, because this one I don't know, maybe there are some Russians here who can confirm. In Russia, apparently, it's usual to have a video cam in the car, because this is imposed by insurance companies to keep under control the traffic accident. So, this dashboard camera image, there are thousands of these, you can find as many as you want on the internet. Now, the peculiar thing is that in some of these images, you see the following. There are two shadows. One from the sun, which is rising, and one from this fireball. And the fireball makes a shadow which is deeper. That is, this object was for a short time more brighter than the sun. Okay? Next. The images, some of these images show something very interesting, that there were in fact multiple explosions. So first something explodes, leaves a remainder, which is still like a large meteorite, and then later explodes again and again. It is now estimated the asteroid was about 17 meters diameter and the mass 7,000 tons. The speed was very large, 18 kilometers a second, which, if you are familiar with the property of rockets, these kind of things, normally you would expect it to have a velocity of the order of 11 kilometers a second. If it rises that fast, means, well, it is particularly energetic. Okay, next. And then, after the bright light vanished, there was a quite long period in which the only thing that could be seen was this very long cloud created by the explosions. Now I have a question for you. If you see a phenomenon like this in the sky, bright light, brighter than the sun, and then the cloud, what do you expect happen next?
A boom.
Now, I think, I suppose, you have been all taught when you were a child, that when there is lightning, then you count the seconds to the arrival of the sound, because sound travels at 1 kilometer in 3 seconds. So you count up to 2 kilometers. Now this was 30 kilometers away. So people had to count to 100, but they didn't. They kept taking video recordings of the clouds. Now, okay, maybe I could have brought this. There are a lot of these videos, and people show this cloud. And then there is a terrible bang, and people know Russian confirm that people use very unkind expressions because they've been so unaware. But this was very naive. Why these people were not unaware? I mean, please listen to me. You see something brighter than the sun, take cover. Okay? Anyway, next. Okay. Next. Then the blast wave arrived. The explosion was 440 kilotons, about 30 times the atomic bomb on Hiroshima. A good part of the energy went in the light flash, but roughly 100 kilotons of energy went into the blast wave. The blast wave was just too weak not to kill anybody, but enough to destroy 200,000 square meters of glass. And as a result, 1,500 people were medicated in hospitals because of cuts from the glass. That is, they were not only taking pictures, but standing below the windows of their house, which fell on their head. Okay? Next. Okay, I want to tell you the positive story. One teacher of a school of Chelyabinsk understood what was happening, ordered to the children to go under the desk, and even try to open windows in such a way that nobody would be hurt. So it is possible to understand this thing. It's just a matter of culture after all. Next question. Does this thing leave a big meteorite? Now this was found several kilometers after Chelyabinsk. It's a hole about 6 meters in something called Lake Cherbakoul. However, it was a long time before scuba divers were able to go down in this dark lake and find out something. Next. And it was October before they were able to recover this thing, which is 655 kilograms. Still, it's not, as in the example I gave you before, it is normal that only a small fraction of the mass of the original objects end up in meteorites. The productivity in meteorites is low. So 7,000 tons, the largest pieces 600 kilograms, and so what can happen. Next. Now, I was let me get back to my point. This is a uniformitarian phenomenon. It happens every day. But some days are worse than others. Some days, something bigger arrives. So what is this thing? This thing was a 40-meter asteroid, but this was a metallic one. So it was also heavy and difficult to destroy. It was not destroyed, the atmosphere arrived in one piece, contact with the soil, and then produced a big explosion. And this explosion produced this round crater. The energy of that explosion was 5 to 10 megatons. This crater is 1,200 meters. It's now called the Barringer crater from the name of discovery, or meteor crater, which is the touristic name. To call this a meteor is not very appropriate. A meteor is much smaller thing, but that's a matter. Okay, I personally knew Eugene Shoemaker, who was the first one to prove that even against the opinion of the majority of geologists that this was an impact crater with an age of about 50,000 years. Now, one interesting question, why is the crater round? Now, the naive way of thinking, which involved also Mr. Barringer, who bought the crater, okay, and he said, well, he knew that it was a metallic asteroid because there are pieces that can be recovered around, and he said, the crater is round. That means the asteroid arrived straight. And then he installed a mine trying to look for iron in the center of the crater and started digging down. What is wrong with this? Well, let me give you the proof that this way of thinking is wrong. Next one. The Barringer went bankrupt, okay? Because he didn't find even a small piece of iron. Okay, this is the first characterization experiment done by mankind. Okay? This did not give a very good result because this atomic weapon was placed on a tower 100 meters high, and therefore the impact was airborne and the effect on the ground was small. But still, this made a crater a few tenths of centimeter deep and several hundred meters diameter. This explosion was called Trinity, occurred on 16 July 1945 by 20 kilograms. And this is, of course, an extreme high-speed photograph. And what it shows? It shows something which is called the fireball. And what happens is that the temperature becomes so high that all the molecules of air run away like mad, and because they run away in all directions, as is typical of the motion of the molecules in the atmosphere is disordered. They go in every possible direction. If they are heated to enormous temperature, they go in every possible direction very fast, and therefore they form a sphere. It does not matter at all. The velocity of the impactor does not matter at all, because the velocity of the impactor is less than the velocity of the molecules, because the temperature is too high. As a result, it does not matter. This was a static weapon. But I'm sorry to make an example, it's not nice, but if you launch a nuclear weapon with a missile which arrives at 10 kilometers per second, nevertheless, the hole is round. And that's why Barringer went bankrupt, because actually the meteorite had arrived at an angle of 45 degrees. Can we go back one step, please? So the iron is here on the wall, not under the center. So poor Barringer excavated the wrong place. If you go there, as a tourist, you can buy one piece of Barringer meteorite as a souvenir at the price.
But not from him.
But not well from his descendant, I don't know. Or somebody bought. Next. Okay. Now, question. Still, it is a fact that on the Earth, as more or less in many planets, there are craters of impact and volcanic craters. How you distinguish them? Now, one method is the Barringer one, which sometimes is ineffective. You look for a piece of meteorite. But sometimes a meteorite is not of an iron, and therefore you may not find anything. Now, I am not a geologist, but geology is guaranteed. But if you find a piece of rock which is like this is called a shattered cone, that can be created only by an impact or by nuclear explosion. Okay, so you find it in the place where nuclear weapons are tested and where there is an impact created. And one interesting also reference to a controversial scientist is a guy called Alfred Wegener.
There.
Where?
Here.
This
This
one?
guy.
This one?
He was a very good friend of Milani-Puclic.
Ah, that's very interesting. Because two people who like to propose interesting theories which are not accepted in their time. Alfred Wegener proposed two theories. One theory was that the craters on the moon are impact craters. He published this book in 1921. A book called The Craters of the Moon. As a result, experiments he did. His second controversial theory was called continental drift. Okay? Then he proceeded to go and explore, since he was a meteorologist in principle, but he liked to do field research. He went to Greenland trying to cross it in a sledge, trained by dogs, and proceeded to die of starvation and cold during this transfer. So he died and was completely forgotten until about 30 years after that. And then, more or less in the same years, in 1950, both his theories, the one on craters and the one of continental drift, became the standard of science. Well, as long as he was alive, also because he died early, nobody had believed him on any one of the two.
Sorry. Why you call him controversial?
Well, at his time he was controversial. I mean, he proposed two theories, and everybody said that his theories were ridiculous.
Yes, but now he's not a controversial.
No, a controversy is something which takes place in time. At some point it finishes because somebody wins. Okay? And he won, but he won 30 years after being dead, which is not nice, unfortunately, for him. I think Milankovitch, I'm not surprised they were friends, because also Milankovitch's theory was not believed for a long time, isn't it? Next. Now, you may find that I'm beginning to be boring, but you can make even larger impacts and larger craters. So this crater is called Gosses Buff in Australia, 5 kilometers in diameter, but geologists are able to reduce that this is the result of erosion. This crater is 142 million years old. Originally was 22 kilometers in diameter. That means this was the result of impact on the ground of an asteroid of 1 kilometer diameter. Now, just an interesting number. A crater like this is formed on average on the surface of the Earth once every 500,000 years. Now, its effect on the living species must be, let's say, impressive. Like one continent wiped out, or whole life, or something like that. Next. Is there, now we'll get to a very interesting question, is there an upper limit of how big can be an asteroid falls on our Earth? Well, there is, but it's very large. So this crater is so large that you can appreciate it only from a satellite picture. This is 70 kilometers, and actually this is seen in winter. Actually in summer it is an annular formed lake of about 70 kilometers in diameter. Originally must have been 100 kilometers, and the age is 214 million years. On the moon there is a crater which is called the ITN crater in its lunar south pole, which has a diameter of 2,500 kilometers. That means it has been created by an asteroid must have been more than 100 kilometers, between 100 and 200 kilometers. So there is a limit, but it's a big limit. Next. Now, let's go back to uniformitarianism and catastrophe. What I'm showing you is like an enormously large picture of the strata I was showing you in the picture of Grand Canyon. This is the interface between two geological ages. The white one is Cretaceous, which is typically white, you know, the white hills of Dover. Okay, Cretaceous means Creta, what do you say?
Creta.
Huh? Chalk. Okay. And this is tertiary, Eocene, but anyway, our age. So this is the age of dinosaurs. This is the age of mammifers. At this boundary, 7% of the animal species known to paleontologists disappeared, including all the species living on land larger than 20 kilograms of body weight. And even worse was in the seas. And the boundary is essentially 1 centimeter. And what, moreover, this shows that there is this layer, but this layer in turn terminates so abruptly that you have to use a knife to try to follow the boundary. Okay? The amount, so this, what is this? This is a layer of ash, carbon, essential product of combustion. Now, as usual, there are many controversies in science. There is no agreement of how much this ash was a fraction of the total biomass on Earth. There are those who say 90%, but others who say, no, that's too much. But it must not have been a nice moment to be there. Let's put it this way, okay? So the surprise, this is my point of view, which is maybe not so much accepted by paleontologists. What is difficult to explain how some species survived, not why people were extinguished, because this seems to indicate a global fire. So an explosion so big that the entire Earth is on fire, that there is no forest which is not burning, so to speak, okay? Now, what was this? Next. I forgot to say, this particular layer is located in Italy, in a place called Gubbio. And this is again the so-called KT boundary. And this is Walter Alvarez and this is Luis Alvarez, which is his father. Walter Alvarez was a geologist. And Luis Alvarez was a physicist, Nobel Prize for nuclear physics. And then the son went to the father and said, could you please measure the amount of iridium in the boundary layer between Cretaceous and Tertiary. Now, I have to explain to you one basic things of geology or even planetary science. Why is iridium rare on Earth? Extremely rare. It's the most rare metal on Earth. Because its specific weight is 22. Okay? So it's the heaviest metal. Okay, uranium is more heavy, but uranium you cannot find as a metal in the rocks. It's dispersed in the rocks. So as a piece of metal, there's nothing heavier than iridium. So if Earth was formed by a bombardment of material which made the surface of Earth hot, whatever iridium was there just sunk and is now in the nucleus of the Earth. As a result, the iridium you can find on the surface, near the surface, is mostly something coming from space. Because of course, meteorites coming from space contain a composition which is similar to the average composition of the Earth, including the nucleus of the Earth. And so they contain much more metal, much more iron, much more iridium, much more nickel, this kind of metals which mix well and are heavy, and mix well with iron. So the idea was, let's try to measure the influx of meteorites on Earth. Why was this important? Well, they've said it's a uniformitarian phenomenon, then I'm making an argument, I'm warning you. What I'm saying is going to be wrong, but you have to understand why, okay? So, uniformitarian argument. Meteorites fall every day. We can compute how much it is, that many tons. We compute how much iridium is there. Then we ask the specialist to measure the amount of iridium, and that measures the time, the duration of exposition to meteorites. So this is a way to compute how much time it took. So the question was this 1 million years or 1 year? How long it took to accumulate this small structure? Why is the argument wrong? Okay, this is a difficult question. Maybe for the students, they should answer that. You should know this. It's a matter of size distribution, okay? So the rule of the game is the following. Yes, there are small asteroids and big asteroids, from 1 centimeter to kilometers. However, in number, the 1 centimeter one are zillions more. But if you compute the mass, all the mass is contained in the biggest. Okay? So what happened next? What happened is that the measurement of iridium in the KT boundary was so large that there was no way to explain it with the meteorites, but you needed to assume, to explain it, that an asteroid of 10 kilometer diameter had fallen on our planet at that time. So the amount of iridium is equivalent to the content of iridium of a 10 kilometer asteroid. And there is no way to do this by using many smaller ones, because the one big is much more massive than many small ones, the many small ones which are around. Okay, the only point is that, again, the statistics of the uniformitarian thing is that this can happen, but of course, the larger the asteroid, the more rare event. So such an event happens every 100 million years. The KT boundary is 65 million years old. So, what is strange? What is strange? Of course, those who were living at that time have been unlucky, but the Earth has got what is normal to receive for that time. Next. Now, I'd like to tell you another interesting detective story. So at this point, this theory was proposed in 1980. I remember going to an international meeting in America in 1988, and the scientists were still fighting like mad in this subject, because this theory of that an asteroid killed the dinosaur, which is a very inappropriate expression. If you think all the dinosaurs are being killed, have you had chicken today? What do you think of it? So, birds are descendants of dinosaurs. The dinosaurs are not extinguishing. Some dinosaurs are extinguishing. But anyway, most of the dinosaurs are extinguishing. So what killed most dinosaurs? The nice theory, but there was no proof. What would be a proof? Crater of scaling low more or less 20 times the diameter of the impactor must be 200 kilometers large. So how is it possible that we found a 1 kilometer large crater and don't find a 200 kilometers? Well, there are two stories behind this. One story that this crater happened to be on the Gulf of Mexico. Half of it is under the sea, and half of it is on land, but covered by hundreds of meters of sediments, as it is normal after 65 million years. The second interesting story is that there were some people who knew that already since many years and didn't publish anything because we were not scientists. Were diggers for oil. And the reason is the following. Have you heard, speaking of fracking? Yeah. Okay? You know that if an oil well is exhausted, what you do? This is better invented by the Americans. You push water at the great pressure, so break the rock, and then the oil arrives to the well. Okay? So what you think does a 10-kilometer asteroid ends up on the Earth. Fracking on continental scale. That is, the crater not only is 200 kilometers, but is completely full with kind of rock which in geology is called breccias. So, if you make a hole in the crater, you get oil. Okay? So this is natural fracking. So, the fact that there was a crater was an industrial secret. And it was not revealed until after the oil exploitation permissions were subdivided among the major oil companies. Okay? Because knowing exactly where was the crater was like the map of gold. You know? So you had to. So, and in fact, this figure which I'm showing is not a figure, is a synthetic image created with gravity anomalies, was created by the investigation done with gravimeter by the oil companies. And just for the comparison, this is a similar map for the crater of the moon, which is called Mare Orientalis. Okay, that's enough. Next. I'm okay, more or less the right time. So, at this point, we are forced to ask ourselves another obvious question. Are we more clever than the dinosaurs or not? Okay? That is. Now that we know that this uniformitarian phenomenon, when it is at a high end, becomes catastrophic, is a danger for very life on Earth. Anyway, the survival of our species, of our civilization, we know it, or maybe more limited way. Just an asteroid a little bigger than the one of Chelyabinsk could destroy a city with millions of people. Are we going to do something about this? Can we do it or not? Okay, so what I'm presenting here is called the 5-step program. It's a plan to eliminate the risk of asteroid impact. This plan has been proposed in 2002 by myself and Milani Puclic. Step 1, telescopes. That is, you have to discover all the asteroids large enough to make significant damage with powerful enough telescopes. Step 2, you have to actually compute their orbits. Not enough to have the observation. You have to extract from this the information on where they are and where they are going. Step 3, once we know where they are now, you have to check whether in the next interval of interest, I say 100 years, they are going to impact the Earth or not. If they can impact the Earth, you try to find them again in such a way that you confirm the possibilities. Well, it's a difficult concept I was trying to discuss with one of you. Because the motion of this object is chaotic, you cannot really make a deterministic prediction of whether there will be an impact or not. You have to express it in terms of probability. But of course, the probability does not mean the asteroid, and we're not speaking of an elementary particle. We're not speaking of quantum mechanics or things like that. You have an asteroid, either it's Earth or not. The probability measures only our ignorance. The probability is not a property of the object, it's a property of our knowledge of the object. So if we compute the probability, that means among the many possible objects there are some which impact. What we do, we observe the object again, restrict the range of possibility until the orbit impacts is out of the possibility. So we continue to observe until we get a probability which is either 1 or 0. If it is 0, no worry, go to the next one. If it is 1, now at the beginning, I mean in the 1990s, 20 years ago, people have started doing something similar to the first 4 steps, but they are not yet answered to step number 5. That is, What if you discover an asteroid going to impact? The answer is, well, the asteroid is an orbit which is in collision course with the Earth, and you change its orbit. You have to deflect an asteroid. Okay? Now don't be scared, this can be done. Can be done with technologies which are available, even apart the fact that some of these people are students from a school. They are doing this. One subject of the school is how to deflect an asteroid. So for us, this is normal stuff. This is sophisticated engineering, but can be done. And so it can be done. Next. So somebody of you asked me why I am interested in this if I am a mathematician. Okay? Now, I apologize, I shouldn't speak of myself, but a little bit of vanity will also leave to everybody. Okay? So this is my work. I'm a specialist of chaos. So what we did is step number 3. Okay, of the 5 steps, 15 years ago, the step number 3. You know an asteroid. Is this asteroid going to hit or not? This was a problem that nobody was able to solve. And this problem was solved by my group, more precisely by 3 people, 2 Italians, 1 American. And in 1999, we found a mathematical method which allows to make a prediction for a finite time span and above a threshold of probability of the possibility of an impact of an asteroid for which we have discovered, not one we don't know of course. Since then, this I'm showing you is our website, and this website contains something which is called the risk list. This is a list of asteroids which are known which could impact the Earth. This list is very long, there are about 500 asteroids. But don't be worried, because if you sum the probability of all of them, it's still very small. So there is no, in this list, although the list is very long, there is nothing to worry about. And indeed, we have not yet started building the spacecraft to deflect an asteroid. There are people here who are already studying the theory in case it is necessary. I think this is a good idea. Okay? So, for me, now, let me say something which is maybe not science, it's more like psychoanalysis. From my point of view, I am a mathematician, my work is very abstract, but at some point I felt the need to do something which I thought was useful. It is a risky choice. You don't have an idea of how many difficulties we encounter when we first find that we are able to predict the possibility of impact. We have to answer the following question: to whom we are going to tell this? Okay? And to be honest, we didn't know the answer to this. With the years, we've now found to whom we should tell. Roughly speaking, you should tell to space agencies. Because in the end, they are the ones who are responsible for making the deflection if it is going to happen. But still, I'm not repentant. I'm trying to do something which is useful. I think, of course, that means I'm a very ambitious man, and I want to be remembered. The question is whether we will remember with glory or with infamy. So if an asteroid will arrive, it has been predicted, will be deflected, and I will have a monument in many places. If an asteroid arrives because I bet or wrong that the asteroid will fall on Earth without anybody in the world, I will be taken out of my town to be hanged in my body or something like that. So, okay, I'm taking a post-mortem this year, so what? I will be that. Okay, I hope I have at least a little interested you. Thank you. And please ask any question or comments you would like to do.
Please slide 3.5.
Sorry?
Slide 3.5.
Go back, yes. That is 3.5. Yes.
What do you call it?
Yeah.
Yes.
this last sentence down, last sentence, last, on the bottom, yeah.
Such an event occurs on average every 100
Yeah,
years.
do you agree that maybe this is too much approximate because in earlier age of space, you know, there are much more asteroids in space, okay? And after time, they fall in, and in time there is less and less and less, okay?
Well,
It means that this 100 million years is time.
okay. Look, what you are saying is not completely wrong, but you are getting wrong with time scales.
Yeah, okay.
Okay, it is true that the population of asteroids evolves.
Yeah.
However, the time scale for this evolution is billions of years. So if I say that this an event occurs on average every 100 billion years, maybe in 2 or 3 billion years this number will be wrong. But 2 or 3 billion years. Okay? So on a longer time scale, the situation may change. But from the point of view of mankind who lives in this particular geological age, this number is fixed, essentially. Okay? So it is true that the asteroids are not a fixed entity, because they collide between each other and produce effect, which, by the way, we also study, particularly myself and Professor Knesevich. But this is an extremely slow process, which is the same nature. Also, this is a uniformitarian process, which is the result of accumulation of effects over billions of years. Okay, the asteroid cannot change quickly, because let's put it this way: outer space is almost empty. Okay, so if you have the idea, the Earth is already a very small ball with respect to the radius of the Earth is. Okay, so that means if an asteroid passes through the solar system, the probability that actually hits the Earth is very small. The probability that an asteroid hits another asteroid is even smaller because the Earth is smaller. So the phenomena you describe exist, but they are very slow. And even the events like the one I'm describing, the fall of an asteroid of kilometers in the air, is an event which is important on geological time scale, but to be honest, it's not going to happen in our lifetime. The fall of an object which is a little bigger than Chelyabinsk and therefore can make serious damage, that could happen in the next 50 or 100 years, and therefore we should do something about that. But the risk of, as an example, asteroid of 10 kilometers which could fall on our head in the next 100 years, there are none. They are not there. Later on, we don't know. But for the moment, we shouldn't worry.
One moment, it's still there. Some geologists think that maybe it was a greater impact than KT impact was in the
Permian
yes,
Triassic.
Permian, yes.
Permian Triassic.
Yeah.
Now,
Is there any evidence about this?
Now, the problem is the following. The KT boundary at this point has been studied well.
Yeah.
And I think that the origin, interplanetary origin of the catastrophe is out of discussion. There has been a long controversy, as I told you, but now it is over. There are, in the geological record, at least 4 big extinctions, of which the one you are mentioning, Permian Triassic, is the biggest one. So it was worse than this one. Okay? But a proof comparable to the one of the Cretaceous-Tertiary boundary that has been an asteroid is not available. There is no iridium in the right place. There is no crater. It is true that the crater has had more time for being erased. But, so there is no proof. In reality, there is no proof of the existence of another great extinction which was created by an asteroid. It is possible. But of course, it's not necessarily the only possible mechanism. And so, please, I think that to discover that dinosaurs were killed. Well, most dinosaurs were killed by an asteroid was a great discovery. But let's not make of this a doctrine which must be applied in every case. It's not theology, this is science. When we have proof, we will take a conclusion.
Can you tell me how exactly does an asteroid explode? Since it's made out of rock or metal?
It explodes in two ways. Either it hits a planet. I mean, if you have an hypervelocity impact, if you have a projectile at ordinary speed, the ordinary speed of a projectile like a cannonball is a few hundreds of meters per second. If this object arrives at, I don't know, there are people more expert than me, above 5 kilometers per second, what is called hypervelocity, then what happens is that the energy is so large that it creates a temperature of hundreds of thousands of degrees. So the asteroid more or less vaporizes, and the fireball excavates. And the fireball, which is really created by the conversion of kinetic energy of the asteroid, excavates a hole and launches a jet all around, in some cases over the entire surface of the Earth. And this, that is, if an asteroid, when an asteroid is in space without being near the Earth, if another asteroid hits a smaller asteroid, a large asteroid, typically forms a crater. If the projectile asteroid is not that much smaller than the other one, can even break it into pieces. Okay? But the event of an asteroid which hits the surface of the solid planet is one of the most energetic events you can imagine, because there is a kind of instantaneous conversion, an enormous amount of energy from mechanical energy, but also solid state energy, into heat. And heat a blast wave.
And when it's above the Earth, then explodes.
Sorry?
When the asteroid hasn't hit the Earth yet.
Well, there is, again, it's a matter of size. If an asteroid is 1 kilometer in diameter, the atmosphere is transparent. Okay? It arrives to the ground without even slowing even a little bit. If an asteroid is 10 meters, it does like Chelyabinsk, big scale. That is, it at some point explodes in the atmosphere and dissipates the energy not on the ground but in the atmosphere. Now, you might be right in asking me, what happens intermediate size? What is the critical value for an asteroid to get to the ground? Unfortunately, I don't have an answer to this. Depends upon also the composition. As an example, I've shown you one asteroid, the one of Barringer crater, was 40 meters diameter. There is a big crater. I mentioned a Tunguska asteroid. It was also 40 meters, there is no crater. And the asteroid exploded at something like 8 kilometers in the air. So the diameter was the same, but the composition was different. Barringer was metal, like a metallic metal, very solid metal. The other one was very weak, like many meteorites, probably ordinary chondrite or even cometary. So, again, you shouldn't think that because we are scientists, we study the subject, we know everything. Knowledge of what exactly happens when an asteroid of large size hits Earth atmosphere is you know, science is based on experience. How you do an experiment with this thing? You cannot do that.
They say the most reliable scientific method is method of trial and error.
Yes.
You try.
You cannot launch an asteroid in the Earth to see
and you cannot do it always.
In case that you discover a baby from the space, who would be in charge to take decisions? Would the public be normally informed? And with this technology, what would be done?
Okay, first important information. Can you go to the last slide, please? This is a website. It is open, anyone can read it. The rule of the game in our work is there is no secret. it's forbidden to have any secret. If we find something like this, it is public, it is on the web. This is also a way to relieve our responsibility. So we have informed everybody who wants to know. Second question, who reads this website? Well, maybe journalists, maybe students, maybe leaders of space agencies, maybe people in charge of civil protection. Some of them do it and some of them don't. Currently, there is a rather important initiative of the United Nations by a committee which is called the UNICOPUS, which is well, the Committee of United Nations for the Peaceful Utilization of Outer Space. So there are discussions going on how we would create a worldwide line of command, coupled as an example of taking a decision on deflecting an asteroid. So, excuse me, but I need to limit my responsibility. I am the one who warns. Then somebody else has to decide. Also because I don't happen to have €1 billion in my pocket to create a space mission, so it's not up to me to decide. Okay? So, I repeat, they're in charge of step 3. Step 5, somebody else.
But is there any authority or the institution at the world level in charge of giving us information?
There is this committee of the United Nations.
Yeah.
There are space agencies like NASA and the European Space Agency who take care of this. There is not yet a fully organized, I would say, line of command in the military sense, which would allow to take a decision very rapidly in case of need. To be honest, this is not there yet. And of course, there are people who are working to create this. At the conference we are going to in April, they are going to run a simulation. Simulation consists in inventing that an asteroid is going to fall in a realistic way, and then close a number of people in a room will say, this is the situation, now what you decide. Okay? This is the exercise that we use this. Because then people learn that they don't know what to do, which is a dangerous situation.
There is no welcoming committee. There is no welcoming committee.
There should be a welcome committee, which is now. There are a couple of complicated questions. One is about nuclear weapons. So, as an example, should we have a rocket ready on the launch pad with a thermonuclear weapon top to be shot at any asteroid if it becomes too dangerous or not? The answer to this question in general is no. Because a nasty computation shows that if you make such a thing, it is more likely that it's used to be launched against somebody else than to be used against an asteroid. So, you have to be ready, but not too ready.
But who will be so crazy to shot by nuclear, for example, Russia or country, but not to asteroid. But asteroid will kill all the world.
No. The problem is that the fall of asteroids is rare. So you prepare something against an asteroid. The asteroid does not come for 100 years.
Yeah.
How many world wars there are in 100 years? Is there somebody who can answer this question?
Yeah.
But at this time they have already the possibility with launches to shoot with an asteroid or jet fighters.
No. If you, the important point is that, okay, I should show you one of these tables. Typically we predict impact which occur in 20, 30, 50 years. So there is time to go there and deflect the asteroid by giving a very small kick. Because you need a very small velocity if you do this 10 years before. And then you don't need nuclear explosion because you can use a conventional rocket and launch at high speed a conventional rocket on the surface of the asteroid. This method has already been studied, by the way, we proposed it 10 years ago. Is now well understood and is technologically feasible. If you know well, enough in advance. That's why, first of all, you need the telescopes, of course. Yes.
My question, what do you mean of that something very safe our planet of the space?
You think our planet is safe or you think it is unsafe?
Very safe our planet on space.
Recite na srpskom, pa ćemo
Pa,
prevesti.
znači da nešto, da li on misli da nešto jako čuva našu planetu u odnosu na druge, znači...
Mislite u smislu prirodnih fenomena ili spiritualnih?
Pa i spiritualnih...
To teško možete da pitate nekog...
What are you talking
Pa
I'm confused. So what was the next?
Pitanje koje možete postaviti njemu, to je da li postoji neki naučni, odnosno nekakav prirodni fenomen koji se može objektivno izučavati, a ovo drugo spada u domen religije, verovanja...
Fenomen, recimo, Bog, ako se Bog smatra...
I will translate the question because some people think that the question is okay, I know. I will translate.
But still question.
The question was whether you think that there is something which protects our planet from the danger from the space, and both in the, as a sort of some natural phenomenon or spiritual.
Okay, I will answer with a question. I know this is a trick, but I wonder whether you agree with this statement. If an asteroid arrives and is going to hit the Earth, that's because we deserved it and therefore we should not deflect it. Do we agree on this?
Pita on vas, odgovara vam pitanjem. Šta vi mislite? Kada bismo otkrili neki asteroid koji je na kolizionom kursu sa Zemljom, udarit će u Zemlju i verovatno će nas sve uništiti. Da li treba da li smo mi to zaslužili, pa zbog toga treba da odustanemo od pokušaja da ga skrenemo.
So because you see, if God protects us, what happens when He does not protect us?
Ja mislim da to nema veze sa mojim pitanjem. Znači, moje pitanje je bilo da li Bog čuva planetu?
A to je, on to je pitao da li. Sad je on, could you repeat this last sentence and I will try to translate.
Because if God protects us,
ako nas Bog štiti,
what is the meaning if something bad happens?
Pitanje je ovo, mislim da je to uobičajeno pitanje kod tih religioznih rasprava, ako se nešto loše dogodi, a Bog treba da nas štiti, šta se dogodilo? Da smo mi zaslužili onda da nas kazni ili o čemu se radi? Dakle, to je bilo pitanje. Znači, vi ste pitali da li nas neko štiti, a on vas pita, ako vidimo da nas ne štiti, da li to treba da shvatimo, da smo to zaslužili, pa da i ne pokušamo da se odpravimo.
Ne, moje mišljenje je samo da nas neka sila ne štiti, ne bi bili ovako, da kažem, bez tolikih meteora. Znači, malo bi mnogo više meteora i Zemlja je bila rasturena, izbačena.
Ja mogu da odgovorim da postoje neke stvari koje nas štite. Naprimjer, Jupiter. Činjenica postoji Jupiter. Nas štiti od toga, to je velika jedna planeta koja se nalazi dalje od Sunca, od Zemlje, i sve što, ili dobar deo onoga što bi moglo da ugrozi Zemlju, dolazi izvana, kao što su komete, recimo i tako dalje, često bili skrenute ili od strane Jupitera, pa ne stignu do nas. Tako da ima nešto što nas i štiti, ali nije to u ovom smislu.
Ali prirodno.
Da, ali su to prirodni fenomeni.
Ako nemate, ja se izvinjavam. Oprostite, ako nemate više pitanja, oprostite, ja bih, if there are no further questions, I would like to present you in the name of the President of the Association of European Actors to this small gift. as a thank you for your effort and for your kindness and your patience and everything. This is partly in Serbian, partly in English. And this is a CD with the same story, so that's for you. And Mr. Slavs is sorry that he couldn't come because he's ill with temperature. But anyway, he sends his greetings and this is for you.
A samo ću vas moliti da vedite mu da je akademik bio najstrožiji kritičar i recenzent tog filma.
This gentleman was the greatest critique of this work, this work.
I was invited, they asked me to check whether everything is okay.
It's a small thing, but it's present and it's...
Okay.
I za čašicu rakije samo.
And
Okay.
yes, if you'd like to join us,
Hvala svima
pridružite ima
što ste došli. Thank you everybody.
Da.
And please join us for negativno početku. Pozitivno generalno.
At least you have been amused, that's good.
No, no. È stato bello come sempre.